There are three diagrams here. Let me orientate you a little bit. We have the same graph, but I'm trying to approximate the area under graph using rectangles being drawn. On the left side, you only have three rectangles. As I move right, I use more rectangles but are smaller and smaller. Can I write in a few observations first on what happens when we go from the left diagram to the right diagram, okay, before we talk about the concepts? So left to right, what you want to observe is I had actually used more rectangles. From the left diagram to the right diagram, the number of rectangles increased. Number two, each of your rectangle will have a smaller width. From a very fat rectangle, it becomes very thin and very, very small. And as we go on, what happens is the gaps between the graph to the rectangle, okay, these are the gaps I'm talking about. The gaps will actually get smaller and smaller and smaller. So you have smaller gaps between your curve and your rectangles. Now, collectively, what is the concept that we are trying to apply? As I go for more rectangles, okay, let me just write here, the more rectangles used, the better is the approximation. Okay, and what approximation are we trying to have? Approximation of area of rectangles to area under graph. Now, the main visualization we would like to have, which is also the concept that I've printed below later on, is therefore, when your number of rectangles tend to infinity, as we go more and more, let's say we put it tending to infinity with very, very small widths for your rectangles, then we will see that area of all your n rectangles will really converge or tends to area under the graph.